So I have wanted to do this project for a while now. Ever since about a motorcycle, this project has been on my mind. I always thought it was very cool to have like a light kit beneath your motorcycle. Light kit are things that look very cool, but are very easily to mess up. Just overdoing the lights a little bit make it look very tacky. But when done right, I think it gives off a vibe of that one car scene that everyone knows. The goal is to stay minimal, just make the motorcycle pop a little bit more with a little bit of lights here and there. Most of the light kits are just static, they just have a single color and that's about it. The more advanced one maybe play an animation or something, and I've seen those do very well on Instagram and TikTok, but I want to do something different that I haven't seen before yet. I want to react to my RPMs or speed. So the animation is dynamic based on how fast the motorcycle is going or how high I'm revving it. This idea has been on my mind for quite a time. Ever since I bought a motorcycle, I've wanted to make this project. But unfortunately, right after buying my motorcycle, I already got into my first accident. And well, that ended the riding season for me. And when I'm not riding, I really didn't care a lot about doing things on a motorcycle. Besides, I had my arm in a cast, so I couldn't really work on this project. So it was postponed to this summer. And I finally started to get going with it. I also thought it was like the best opportunity to get started with open source hardware. It's been on my mind ever since I did some courses here and there, and I really want to contribute to open source hardware. I think this project is like a very great start to start with it. So this video, or well, video series, is about that. Just creating this whole light kit process. And I know, splitting it up into parts, it really sucks. But trust me, it really makes sense for this one. I know that a lot of people don't really like watching like hour-long videos, so for a case like this, I really have to split it up into 3 parts. But again, it's gonna be worth it. By splitting it up, each video can have its own specialized topic. Like the first video is going to be about the prototype. This video that you're watching right now. The second one is going to be about like making it more professional, and the third one is going to be about the development tools that I've been building. Because a project like this isn't something that you just slap together, you usually build stuff around it to make it work real well. But the idea is very simple. We have a motorcycle, we take information from it, filter out the data that we actually need, and then pass it on to like a light strip that will then display an animation based on the information that it gets from the motorcycle. On top of that, other features will also be added, like a interface or power protection. Because of course something like this has to be easily controlled. If I have to be riding, I should be able to switch it off or switch it on whenever I want, because you don't always want it on. But we won't include it in this video, because this video is going to be about the prototype. And a prototype is a very stripped down version of the eventual goal. A prototype is important, by the way, especially for a project like this. It has multiple parts and all of these parts can go wrong. So just building a minimal example for it to work is very important. Because I knew that this project would take quite a long time, I first needed to know if it was actually gonna work. So yes, for the prototype I'm gonna be stripping away the interface, and I also do away with some protection kind of stuff. If I only get like a few seconds of it working, it's already fine. I just need to see it work, and that's about it. Alright, so the first step is actually just to get the data from the motorcycle. Luckily, a motorcycle has an OBD2 port. We can take everything that we need from here. But we first maybe have to explain OBD a little bit. OBD, or well, the thing I'm actually referring to is OBD2, is just a set of rules that in most regions is actually required by law to be followed by car manufacturers, but also motorcycle manufacturers. It provides a standardized way to access the internals of a motorcycle, so mechanics or the dealership can read out the data from your vehicle. But like with most standards, these are very loosely defined. It really just defines a standard connector, but a lot of the pins are undefined, and the manufacturer can do what they want with them. But there are a few ones that actually are defined. Reading through the standard, we can see that we have access to the battery with the 12 volts and also the ground. That's all we need for power. But also for the data, we can use the CAN high and the CAN low. So moving on, we might actually have to explain what CAN is as well. So let's just do that. CAN, or Controller Area Network, is a serial protocol that works on a differential signal basis, which means you don't just have 1 and 0, but you have a big difference or small difference if we subtract the two voltages from each other. One of the big advantages is that it's very resilient against interference, which makes you able to create a very big network with cable that can span across your whole entire vehicle. I don't know if you've ever seen those pictures with like the car and their internal systems, and you can see that there's a lot of cables going through everything. Also going through like very sensitive components that create very strong magnetic fields. So you really would need something that's very interference protective. You also have some additional features built into the CAN, like its arbitration method to make sure that no communication is overlapping and higher priority signals get resolved first than lower priority signals. You also have bit stuffing, which is just a way, because of the clockless signal, it has a way to keep track of time. A vehicle usually has multiple of these networks. It has one that's very protective inside of its powertrain, and then it has one with a higher level up, and then maybe one with another level built on top of it. And they very heavily control all of the data flowing between these different levels of access. These are just protection measures to make sure that nobody can control the engine from outside. The CAN port exposed on the OBD connector is usually one of the very higher levels of access, so you don't have control over everything. It's usually just used for mechanics or shops to read out data from the engine, and you're not really meant to control it from there. But that's basically all we need. We just need data so we can just use this port. But even though you're just reading data, some manufacturers also protect this channel. They use encryption or rolling IDs, which make it very hard to get the right information that you would need. It's still possible, but you would need a lot more work to be done in order to extract the information. Luckily, my motorcycle doesn't have any of these protection measures, so I don't have to worry about this. So now we have like a theoretical base of how we're gonna extract the data. Let's actually try to make a proof of concept. Proof of concept is basically a more trimmed down version of your prototype, just isolating one specific part of the project, just to make sure that everything works. If my proof of concept doesn't work, there's no point in continuing to making the prototype, because my prototype is based on my proof of concept. These proof of concept can easily be made on a breadboard. All I need is just a connection with my motorcycle and be able to extract data. For this proof of concept, I use one of these little modules that you can see over here. I bought them on AliExpress, they were very cheap and really got the job done. Normally I'm not a big fan of Arduino. I tend to lean more towards the Raspberry Pi boards in order to do all of my testing. But for a proof of concept like this, it really worked quite well. These boards work on a 5-volt logic level, and I'm lucky enough that the Arduino Nano also works on 5 volts. So just to get a proof of concept going, I plugged them into a breadboard, connected it up to a motorcycle and just tried to read anything from the motorcycle. And I was able to read something. That was pretty nice. I was able to read a lot of data, but well, I still had to filter through it. I then had to build a tool that was able to filter for the right value that I needed. I didn't really know what ID corresponded with the RPMs, which is something that I really needed. I then remembered something that I learned during game hacking. In game hacking, you usually use a program like Cheat Engine to find values that you would need to edit. It works on a very simple basis. You start up a game and you see that your health is 100. You make a scan of all of the values that there are, you try to get hit, your value goes down, and then you will just ask the program to scan for any value that went down. You then try to get a heal, make it move up, do another scan, see what changed, and basically you will start eliminating a lot of variables until you have found the right one. I created something similar. It basically just makes a scan of all of the values that the CAN bus reads and makes a snapshot of it. I then rev my motorcycle, I then make a scan again and ask it to just discard anything that didn't go up. I then release the throttle again, I then do the same thing, make a snapshot and then say, okay, all of the items that didn't go down, remove them. This way I managed to find the ID that corresponded to the RPMs. And I can do the same for anything else. Started to do this with speed and maybe also some other values that are of interest. Some would be a bit harder to do since it's very difficult to get them placed arbitrarily very high. But for those things you have different tactics to find them. But so far I was very happy that I could already do this with the RPMs. So this proof of concept is a success. On the other side I needed the lightkit to work. So I also had to make a proof of concept for that. I hard-coded a pattern into the Arduino Nano that would basically simulate a read from the motorcycle. I then went up to a room, hooked up a NeoPixel light strip and just started to play with some animations. This proof of concept was pretty easy. There are many people that have tried this before, just to drive a light kit. But I just wanted to make sure that I found an animation that I really liked. I really wanted to set up for something that resembled a bit of fire. I remember that in the NeoPixel library, you would have an example for fire. So I kind of copied a little bit from that and then tweaked it to really match the feeling that I was going for. I tested it out and the results look very promising. So now I only had to throw away the hard-coded pattern and just throw them both together and see how it goes. So the first signs look very promising. This means that I can move on to the actual prototype. So right now I have to be thinking about actually building everything into my motorcycle. I need it to be a bit more rigid and it needs to be small enough to be actually placed inside of the motorcycle. I also have to think about the connections that I would have to be making and how I would route everything inside of the motorcycle. Space is very limited on one, so I really had to think it through. It had to be able to survive at least like a week. And one of the things that I was worried about were the light strip being affected by the weather. So I had to waterproof them some kind of way. Usually they come in like a silicone tube, but I had to remove it so I could cut them up into the right lengths. So I settled on like a PVC shrink wrap that I would put around and I would then heat it up so it would make a watertight seal. On the ends, I would connect connectors and seal it with like some silicone glue, and also terminated the connector on there, so it would be way easier to install. If I would do everything all at once, it would be very difficult to route it all the way through. So I did it in 3 parts. They would still have 3 cables laying around, but I didn't really like the way that it looked. So I got like a cable sleeve and also pulled the cables through that. The light strips were now actually done, so I could move on to the control board. I wanted to put everything on a perf board, but the components didn't really fit on there quite well, so I had to reverse the pin connectors. I desoldered the headers and flipped them around so I could easily solder them onto the perf board. It was time to make the right connections. I first tried the most common method of using the solder wire to make bridges in between, but for me it really didn't work that well. I just got a very big clump of tin and I didn't know how to solve it. My soldering skills on perf board just suck. So I just decided to still use wires. I soldered some wires to the bottom side and can make the right connections. But even after some struggle, the perf board came out somewhat fine. Again, I really didn't care if it looked that professional, it just had to work and survive for at least a week. I also made a very simple enclosure box, but it's just a box with a couple of holes, really nothing interesting to show. So I won't be going over the build process for this one. I placed everything inside of the box and mounted the connectors. I then soldered the wires from the connector to the perf board, so that was also all set. So right now I basically have a finished prototype. I just had to test it one last time before I actually mounted it inside of the motorcycle, so I did. I went to the motorcycle, connected everything up, and lo and behold, it actually didn't work.
Okay, so live reaction of this thing probably blowing up, because I have no confidence in this thing actually working. Yeah, it's a bit finicky with the wires, but let's see. Get this one in here. Okay, so they should be plugged in, and I probably shorted something because that's how I am. That's just normal red lights.
But it wasn't because I made a mistake in the prototype. It was just a stupid fault when I'm connecting it to the OBD connector. Once I actually found the issue, it actually worked just fine.
I did see some lights go on. Oh fuck. Plugged in the wrong one. Of course. Oh, am I seeing something? Fuck yes, the lights go on. Whew. Okay, this is fucking nice. I didn't think this would actually work.
So that's great. The only thing that was left to do was just to mount everything to the motorcycle. I did a quick poll with the people that I know on Instagram to ask where I should put the light strips. I already had either put it in the front or in the back, or maybe actually both. But my first plan was actually to do the one or the two, because remember, I wanted to stay minimal. I placed this on Instagram and the results were quite mixed. So in the end, I still decided to go with both. But in the future, I want to have a way to enable or disable some regions on the motorcycle in case it does ever get too much. Also, already a disclaimer, the lights in the front bottom are gonna be removed. I didn't really like the way that it was this bright, as it was way too close to the ground. So I removed those and only stayed with the lights on the side, on the front and on the back. But in order to mount this, I kind of had to remove the fairings because I want to stick them on the inside. I thought a project like this might actually be of interest to my brother as well. My brother is a mechanic and he has a motorcycle shop. So I asked him if he would be down to help me. He was quite excited when it came to him with the project. While he didn't fully know what my plans were, he was down to help. So he told me to come by the garage in an evening when it wasn't very busy, and I agreed. I loaded up my motorcycle, drove to his shop, and we started working. At first, I just wanted to have some space and the tools available. But in the end, he actually wanted to help me as well. I'm not that strong mechanically, so it was very nice to have a little extra hand of disassembling the fairings. The idea was very simple. Take out the fairings, use some silicone to mount the light strips, and then just put it back on, making sure that the connector was in a place that it was still able to be connected. So we did. We started disassembling everything, and it turned out it was quite a pain to get them off, but in the end, it kind of worked. longer than expected. So after having done the fairings and put them back, I decided it was time to call it quits. I haven't done the backside yet, but I thought it was fine because I could come back the next day. Even though I knew that next day I wouldn't have his help, I would still be able to come by the garage and use all of the tools. I still had to install a tail tidy so we could just do both at the same time. So now that the light strip is in place, I could just test it with some wires just to know that everything is connected correctly. I then drove it back home where I actually installed the electronics box. For this project I specifically bought an OBD cable. It isn't actually this one because the one that I bought didn't have these two split wires, but it was a single one. But somehow I lost it, so I can't show you guys. You get the idea. I bought one of these, but the issue is this stem over here. It's way too long. I really want to drive it when the seat cowl is on, but if this thing is sticking on top of it, the seat cowl would press onto it and it couldn't close anymore. So I had to design my own OBD connector. I quickly did, just got the measurements, but the pins were an issue. So at first I was quite stupid. I just used the male crimps that you would put on top of the cables if you would design them your own. I hot glued them in, but it turns out that those pins are very bendy and flexible. I initially thought that was actually a benefit since it would bend into the shape of the OBD connector, but in the end it really didn't turn out that well. Currently the OBD connector that I made myself is the weakest point, but it worked. I designed a quick enclosure in 3D, terminated all of the wires, and now I have a makeshift OBD connector that was actually able to be used while the seat cover is on. But luckily everything works as expected. Every time I want to enable the light kit, it's a bit finicky with the OBD connector, but it works. One of the other issues that I found is the light strip on the right side is actually behind the coolant pipe, which makes it way more dim than on the left side. This is also something that I try to fix in the future, but so far the results are very cool. I already took my motorcycle to a couple of meetups and people were surprised. They thought it was very cool. I of course also showed my brother and he was also very positive about it. He liked the way that it was very minimal but still gave a very cool effect, especially when you're taking off from a red light, because then you can really see the motor go into the higher RPMs and then shifting up where the lights drop. It really sells on the flame effect that I was going for. But well, of course telling you about it is very fun, but seeing it is way better. So let me just show you a couple of montages that I made. Well, of course it's time to look back on the project. One of the first things I want to know is that I greatly overestimated this project. I initially thought it would only take like 1 to 2 months, but this project already started in May of 2025. And right now, when I'm recording this video, it's already August, and I'm still not done. I'm still working on the second video and also the third, but this includes PCB design and I really overestimated how long that takes. But so far, this prototype is actually a success. It works and I think it's actually worth spending more time on. So the improvements that I've listed are definitely coming. I've already ordered some of the PCBs, so expect something cool very soon. These improvements will hopefully also fix some of the key issues with this current prototype. There would firstly be a way to control the light kit. Currently I have to stop the motorcycle, take off the seat cowl, plug in the connector and also have to unplug the connector if I want to stop with it. That's less than ideal. I also want to be able to change patterns while I'm riding, So this way I have a way to control the light strip with just an interface. I plan on making one with 4 buttons or maybe 3. I still have to figure that one out. And a nice screen so I can actually see what's going on. I then also have to figure a way to make them communicate with each other. But that shouldn't be too hard, I hope. I also want to add some protection circuitry. Right now I'm using a very cheap buck converter from AliExpress, which doesn't have much protection circuitry. I'm hooking it up directly to the motorcycle battery. And a motorcycle battery isn't really known for being the most protected circuit. First of all, the voltage rapidly changes. While the nominal voltage is 12 volts, you can easily see it dip to 9 volts or sometimes 15 volts in my case. So having it strongly regulated is very important. Also, inside of this cable it's quite common to find some voltage spikes, and you would really need some circuitry to be able to withstand all of these troubles. So some protection circuitry is definitely needed. I also need way more memory. The Arduino Nano that I've used for the prototype is already barely able to store the very simple animation that I've on it right now. But I really want multiple animations, so I definitely need bigger flash memory. Also, something that I've mentioned a couple of times is the OBD connector. It really sucks. There are multiple times already that I thought that I'd broken the pins, but some way I still managed to bend them back and it managed to go for another run. But this can't go on for much longer. I really need a proper connection with stable pins and the right pin spacings, so I'm able to connect it all reliably. I don't have the means to order a custom cable, so I think I still have to make the connector myself. But this time just with better materials and a more rigid design. A smarter design is also something that I want to be going for, because currently the box barely fits inside. I do have more room lengthwise, but the width is gonna be the biggest issue. So I'm probably just gonna try to elongate it and smallen it down. Besides, going with a custom BCB should already shrink the total size by quite a bit. Also, I might have to revisit the light strip. The idea is very good, but the PVC shrink wrap is already deteriorating, so I might have to find a bigger fix for that. Also, I might have to take up my fairings again and replace or relocate the current light strip to a better location, so it isn't behind the coolant pipe anymore. But if those projects are tackled, I think I have a very nice product. And I think there actually might be some people out there that would really take interest in this kind of project. For the people that actually are interested in the project, you can follow me on GitHub. I'm pushing all of the changes that I'm making to there. So if you guys want to try to make it yourself, you can just take a look there. But do keep in mind, if you're watching this video when part 2 and 3 aren't yet out, it might be that you're looking into a repository that isn't cleaned up yet. During the debugging step, I've quickly just put everything up online so I could get help from other people. It doesn't look pretty at all, but I promise, I am gonna do my best to make this repository look professional and easy to understand for everyone. When part 3 is up, I should also have blog posts on the entire subject. And as always, the videos kind of serve as an infotainment kind of way to get people interested inside of the project. But if you actually want to build it, I would recommend to read the blog post on the topic. If the blog post is already out, you can find it down in the comments below. Also, if you guys do have some recommendation for the project, don't hesitate to leave a comment or to go to the GitHub repository and create an issue with a request. Perhaps we can make another version and keep making this project better and better. That's also the power of open source. But for now, I'm gonna leave it at this. The results are great and worth sharing, so that's why I'm also making this video already. And because the results are so good, I'm gonna be leaving you guys with a couple more clips of the entire project. But for now, see you guys on another day on another project.
Ja, ik ben aan het werken, jongen. Laat me werken aan mijn motor.